I am at Blue Origin's headquarters in Kent, which today is the site of the Washington State Space Summit. It's being led by Democratic U.S. Senator Maria Cantwell. Her special guest is NASA Administrator Bill Nelson, and we're going to hear from a whole slew of people, from the CEO of Blue Origin, other people involved in Washington's space-related aerospace industry, which, according to Senator Cantwell's office, creates more than 13,000 jobs, about $4.6 billion in revenue each year, just space-related. We'll also hear from some people in aerospace education. So lots to talk about. I'm going to start actually with the news conference that Administrator Nelson and Senator Cantwell held, and then we'll put the summit panel discussion in there, as well as some interviews with some of the people who had their wares and what they're doing on display in the trade show part of this summit. So a whole lot of stuff to watch ahead, and so please stick with us. Here inside the Space Summit, they're starting with a trade show, and of course, since we're at Blue Origin, there is a mock-up of the Blue Origin New Shepard space capsule and the spacesuit also used.
We have a number of reporters here, and we're not going to do any openings since you got to see a whole bunch of talking out there. We're here for you to ask your questions that you so politely held during the question and answer session. So I'll let you take it from here. Who do we have? Dominic, do you want to start?
Yeah, I'd like to pin down the Manufacturing Institute that you mentioned. You want it, you're saying yes, ma'am, to it. Is it going to happen, and what exactly is it?
Well, at the Department of Commerce within NIST, the National Institute for Science and Technology, NIST, it invests in helping manufacturers stay competitive. We think they should create one in aerospace manufacturing. So, because NASA would work jointly with the Department of Commerce, we've asked their opinion about this, and I'll let the administrator give his opinion about it. But I think he can see from today why this is so important to our competitiveness. The fact that the manufacturers here today saw a lot of examples of composites and got a sense of why it's so important to stay competitive in the space sector on composites.
First A from NASA is aeronautics, the National Aeronautics and Space Agency. And as a result of that, a lot of the manufacturing that benefits space also benefits aeronautics, and vice versa. And so that's Maria's idea. And there are 16 institutes of technology. And yet what Maria wants to do is to refine it more into a manufacturing which would include the composites, the thermoplastics that she has mentioned, and it makes sense. And so we have a study going on with a couple of other agencies, Department of Defense, Department of Energy, that's going on now. There'll be a report later on this summer, and on the basis of that, I think you'll get the green light, and then they'll go ahead and if we don't have the authorization in law for this, they'll set it up. We may have that authorization already.
And it will be an academic center, or what?
So we've been having lots of conversations with everybody in the region, which is not hard to do, but it's time consuming. And so we've been in conversations with academia about this, with manufacturers, the supply chain, and really actually workforce, labor organizations as well, people who are already involved in aerospace training. So we've been trying to get the input. Most of those conversations have been led by Richard Duane and could give you a lot of details about this. But I guess if I said the segmentation of it is to make sure we stay competitive on the R&D side of it, which is changing and shifting, so there is a lot to stay competitive on, and then translate that faster to the manufacturing base and simultaneously skill the workforce, which we know we need to do, but then we would be skilling people in the new types of manufacturing that would help us be competitive. So it's basically saying in the United States, which does employ about 2 million people in aerospace, that we think a new phase of manufacturing will help us maintain competitiveness, and we ought to get about making sure that that happens, because there are so many great aviation manufacturing jobs. So it's a little, I'm not saying it's tricky, but it's a little hard because you have to talk to the space people about their mission, which their mission is, I want to figure out how to manufacture for space. And at the same time, talk to people here about, well, how does that high rate production in thermoplastics affect the aviation industry overall? So it's all the same. You need the R&D, you need the workforce, and I don't know if anybody else wants to comment on this. So I see nodding heads of people who know what I'm talking about, but I think we saw today that the space sector needs this as much as the aviation sector needs it.
There are 16 of these institutes. There are 2 more that are coming online, and this would be the 19th.
Ryan?
So for Administrator Nelson, it's no secret the Boeing Starliner program has hit a couple of speed bumps along the way, the latest being the parachute straps and the potentially flammable tape. How would you gauge the potential of reaching the point of putting crews on the Starliner versus the possibility that we might have to rely solely on the SpaceX Orion?
Well, first of all, we don't fly until it's ready. I'm anticipating that it will be toward the end of the year that Starliner will fly with the crew of 2. I think that we will have what we had asked for to begin with, 2 spacecraft, commercial spacecraft, to go to and from the International Space Station. So that's a quick summary. By the way, in describing NASA in the former question, aeronautics and space, with what I said at the end there in the meeting, we are a climate agency as well. You think about it, all the instruments up there that are measuring what is happening to the Earth. We designed them, we build them, we launched them, and we operate many of them in addition to NOAA, the National Weather Service. And so this is absolutely essential for the future of our planet, that we understand what's happening and then act on the basis of information in order to do something about it to save the planet.
Okay. Oh, Kristen?
Hi, how are you guys more immediately trying to help local businesses here in Washington increase reusable rockets and fight these barriers to make Washington a leader in aerospace?
Well, practically everybody we visited today said they had a NASA contract, and we have tried to authorize, as part of Chips and Science, authorize NASA's ongoing programs in this area. We think the research and development that they represent as a partner is really good for the supply chain. It's really good for the entire supply chain because it just helps people here who are building to build for space and to build for aircraft as well. But I don't know if you want to comment on all the NASA contracts that you saw today.
It's just amazing how we have, let me put it this way, we got 100 things going on at once. Everything from the James Webb Space Telescope, with the rover on Mars, with the helicopter on Mars, with hitting an asteroid bullseye, to the human space program in low Earth orbit and going out into the heavens. And all of that, NASA doesn't do it by itself. It does it with our partners. And that's what you're seeing some evidence of here today.
Do you know specifically how many partnerships you have here in Washington?
Well, as these say, there's 13,000 space jobs, and so my guess is there's probably hardly anybody who's in the space business that doesn't have some dealings with NASA.
We actually have a question from Lorinda, who had hoped to ask it, and we ran out of time during the question and answer from the audience. But go ahead.
Board sovereignty is abused a lot today, and I was curious on how you incorporate tribal nations into the industry.
Well, first of all, I'm so proud of the Northwest Indian College and your great competition on rockets. The fact that you beat MIT, I just love that. And, you know, I'll leave it up to the administrator for an official NASA response, but I do think we should explore more ways to work with Indian country, particularly, you know, on the speed of things, in getting things done. I think that represents clearly, though, a lot of launch capability is all about being close to the equator, and so that doesn't give us a ton of opportunity up here in the Northwest, but we want to continue to work with more diversity and see if maybe there are unique ways to work together. I don't know.
Remember I talked about diversity in NASA and we take it seriously? Did you know that one of the immediate past commanders of the space station, Nicole Mann, is Native American?
We just have time for one or two. Mario?
Yeah, I have a quick question one for Senator Campbell and one for Administrator Nelson. So, in order to have a successful space-based economy, you have to secure the ores, but technically rare metals and elements. And with current geopolitical tensions with Senator Campbell, what policies are being done to secure those rare elements and metals for the economy, but then also from Administrator Nelson, what legislation is still left to be done to support like asteroid mining? Because I heard that's like a $30 trillion company.
So there's lots of things being done on rare earth minerals, everything from recycling to synthetic to partnerships with other countries to our own activities in the United States. And I think the Energy and Natural Resources Committee that I serve on is looking at legislation that would help do that. But we've been a big fan of, particularly we've had a lot of panel discussions from experts who want us to look at you know, our own U.S. production in new ways, like recycling and other materials.
We have several missions that are examining asteroids to see what they're made of. So there's an asteroid called Bennu, and we snuck up to it, and we had a spacecraft that had an arm come out, and it had like a vacuum cleaner, and it sucked up material, and that material is on the way back to Earth right now, and will land in September. We are constantly a mission called Lucy that we, did y'all ever hear the Beatles tune, Lucy in the Sky with Diamonds? Well, we've got a mission that we launched last year, and it's going out to the asteroid belt in front of the orbit of Jupiter and behind the orbit of Jupiter. And we're going to examine those asteroids to see what they're made of. And all of this is looking to the future. In fact, is that a possibility? Now, you quoted a number. I don't know any such number because we haven't proven that we, in fact, know. But what are asteroids? Asteroids are these pieces flying through space for billions of years that have been crashing in to planets and suns and all of that. And no telling what some of them are made of. And so is there a future of asteroid mining? There could well be. But we are trying to find out. And that's what we're doing now in the finding out exploration phase of this whole thing.
I'm going to stop this here, but if there are any other follow-up questions, we have Callie here and Sophia somewhere here.
I would be remiss if I didn't pay a visit inside the New Shepard capsule. I can do it without banging my head, which is.
But yeah,
how
so
it goes.
you have 6 seats in here, 6 windows, they're all window seats, and there's no pilot, there's no flight attendant who flies. We train the astronauts for about 2.5 days down in West Texas at our launch site before their flight. So the purpose of that training program is to get them to the point where when they fly, the only novel experience is the view outside the window, right? So it's muscle memory, everything from getting in and out of the seat, both in 1 gravity and in 0 gravity, because they're 2 totally different techniques, as you might imagine, to emergency response scenarios. So getting ready for like all those edge case things that could happen. Yeah, so any questions about what you see in here?
What do the screens do?
Oh yeah, so those are the flight displays. So those show important information from the flight. So they're going to show like your velocity, the G-forces that you're experiencing, and major events. So they'll call out MECO or main engine cutoff, separation, point of re-entry, when you're above the Kármán line, things like that. So yeah, it just gives you some additional situational awareness of what's happening. But the view outside the window is where most people spend their time looking, and that is the most common thing that astronauts have said by far that they wish they had done more of or known before flying is to just focus on spending time looking out the window versus doing somersaults and stuff in space, because that's really the impactful thing is getting that overview effect. It's even called. It's such like a pervasive thing that astronauts have described. Seeing the fragility of the Earth below and the void of space around is that kind of like fundamental shift in consciousness that you get from that. So spend more time looking out the window. Yeah.
What's the average trip time? Launch to.
Yeah, average time is so from lift off to the capsule landing. It's about 12 minutes. Yeah. So it is a trip straight up above the Kármán line and straight back down.
So I have a question for any of you that want to answer it. How do those seats feel?
Man, super
They're really comfy. Yeah.
Do you think you'd feel comfortable shooting up off the ground and at the top of a rocket in those seats?
I think so.
I mean, there are straps that strap you down.
Yeah, so you have a 5-point harness that we don't have installed right now just to keep them nice and pristine. But yes, that 5-point harness, kind of like a race car harness, keeps you nice and secure in the seats. The seats are also individually adjusted to each astronaut, so there's a whole bunch of different things that we can swap out on the seats to make it a nice, secure fit for you. And the other thing you'll notice is that they're permanently reclined. So that is to allow you to take the G-forces on both ascent and descent through your chest versus through your head. So it's a lot more manageable for the human body to take G-forces in that orientation that you're all in. So that's why we keep the seats reclined like that.
Now this capsule's a mock-up and not one that would actually be used in a flight, right?
So this capsule is a mock-up, is not a flight capsule. However, everything that you see in here is essentially flight-like, including the seats are actual seats that have flown to space. So this is a identical replica in terms of the dimensions and in the parts that you're seeing around you. Yeah.
Fabulous.
Yeah. Cool.
So what you are looking at here in these little box displays are simulated extraterrestrial materials that can be used for a wide variety of purposes. The company that's working with these is called Off Planet Research. This is Melissa Roth with Off Planet Research. Melissa, let me start by just having you just give me like a quick rundown of some of the applications for these materials.
Absolutely. So there's a wide range of needs for the space industry, especially as we look to have a sustained human presence in space. And so it can be everything from developing rovers or the different mechanisms, manipulator arms that's going to be on those rovers, to solar panels that are going to provide power at the lunar surface, to agriculture. How are we going to be able to feed the people that are going to be staying on other planetary bodies? Also looking at spacesuits. How can our astronauts go out and explore the lunar surface and accomplish their goals and still be able to come inside and not bring all of that dust with them? So we're really glad that we can support a wide range of our clients' very specific and unique needs.
I'm assuming NASA is one of your clients?
Yeah, we work with a lot of different types of organizations, including domestic and international government agencies, research institutes, universities, as well as private companies.
Excellent. So, if you wouldn't mind, could you tell me about a couple of these materials?
Absolutely. So we like to start with the feedstocks. That's a great place to do that. And we have basalt, which is pretty common on Earth. But you want to make sure you find a basalt that is similar to what is on the moon, at least as close as we can get here terrestrially. We also have anorthosite. That's much more rare here on Earth. And the anorthosite is much more prominent in the highland regions of the moon. That's where some of the later Apollo missions went, and where we're looking at for the South Pole is also more of a highland material. Conversely, you have the Mare material, which is much more basaltic. And so really, how can we prepare all these different technologies and our astronauts for operating in a range of different materials and soils, and how is that going to impact their ability to accomplish their mission goals?
If I remember right, it was quite a discovery when they found anorthosite on the moon, right?
Anorthosite was something that we knew about here from Earth, but it's very prominent on the lunar surface. And it's not something that we interacted with too much in the Apollo missions. It really was towards the end that we started exploring those areas. And so it'll be really interesting as we go further from the equatorial regions into much more highly anorthositic materials, how that might change some of their properties.
Now, you'd also mentioned agriculture. Are you able to simulate materials that people who might be staying long-term on the moon could use to then grow their own food?
Yeah, so really what we like to look at for our agricultural clients is, are you going to bring that raw regolith in from the lunar surface, all that dust that you're trying to keep out of the habitat, or are you going to look at pre-sieving or altering that material in some way before it comes in? And I think the answer is probably going to be yes. But that's where we work with our clients to really look for what their needs are. Are there certain chemical or mineralogical specifications that are going to be important to them that maybe aren't to our rover clients? And is there something that we can provide as a more custom option for their specific needs?
Now, can you talk a little bit about, without giving away any proprietary information, of course, the testing process? As you're using these materials and working with your clients, like how they're using it to test what they're doing.
Yeah, so I like to approach simulants as engineered test materials. How is this material going to interact with their different testing setup or experimental procedures, and how is the environment and those other testing variables going to influence it as well? So how might humidity actually really affect the flow rate of this material or the compaction of this material? How might how they have it stored long term affect the simulant as well? And so those are some of the considerations that we like to have with our clients, and how they can utilize the material to best meet their specific needs.
Now, you already touched on not bringing it back into a habitat, getting it off the spacesuits, and before we started kind of discussed a little bit about keeping it out of like electronic equipment. Is that part of the process here, is basically trying to figure out how to keep some of this stuff out?
Well, we are producing it, and so for us, we're trying to keep it in. But a lot of the same concepts are going to apply to keeping it out of a habitat, keeping it out of an enclosed rover or the spacesuit. And so those are considerations that we have as well, and why we've started looking at how can we use our expertise working with a very fine abrasive material to develop dust-tolerant mechanisms that might be able to help survive in this really harsh and different environment than what we're used to here on Earth.
Excellent. Well, I, speaking personally, am super excited about the future Artemis missions. I imagine you're, since you're essentially working on a piece of it, you're probably pretty excited yourself, right?
It's wonderful that there is this focus on going back to the lunar surface and how we can really learn so much more about that environment and how it relates to humans' ability to have a sustained space presence on the moon, on Mars, in deeper space.
Fabulous. Melissa Roth, Off Planet Research, thank you.
Of course, thank you.
So a big participant in America's space program is, of course, Aerojet Rocketdyne. They have facilities all over the place, including Redmond, I believe. Redmond, is that right, Sarah?
Yeah.
Okay. Just had to make sure I had it right. And this is Sarah Shark. She's with Aerojet Rocketdyne Business Development. Tell us a little bit about what you're displaying here at the Space Summit Trade Show today.
Yeah, so we're trying to highlight all of the different types of in-space and launch vehicle propulsion that Redmond provides, specifically supporting NASA programs, but we also support defense and commercial applications. So the latest things that we're very excited about, obviously, are SLS and Orion. We have propulsion on the crew module, service module, and the Orion capsule itself. We're also very excited about the APS electric propulsion system, which will be supporting the power and propulsion element for Lunar Gateway. We're very excited for that one coming. Once it's operational, it'll be the highest power electric propulsion system in space.
Well, now I have to ask, and you don't have to get into the deep science of it, but when we're talking electrical propulsion, that's a little different from chemical propulsion, right?
It is. So it uses magnetic fields and electrical fields to help more efficiently move the propellant. So these are things that are much lower thrust, but a lot more efficient way to use the propellant to help you get to where you need to go in the most efficient way possible.
So basically the first step to warp speed is what you're saying. No, not necessarily, but
If only.
I know it sounds great. So now, in what situations would you use that?
So right now, electric propulsion is being used on commercial and government satellites to help with station keeping. It's been used for orbit raising in the past. For the Lunar Gateway, it's actually going to be helping move both the power and propulsion element and the halo element that they've decided to stack together to help move them into their orbit around the moon. So without the electric propulsion system, they wouldn't be able to move both of those elements together into their orbit just based on launch vehicle weight restrictions.
So you also mentioned the SLS for space program novices. That's the Space Launch System being used for the Artemis program to return us to the moon. Now I know there's a couple of Aerojet Rocketdyne products on there. The RS-25s, which are the workhorse of space exploration. Those were when you see the three main engines on the back of the old space shuttles, I remember when the space shuttles were brand new. Those are the RS-25s, the kind of bell-shaped engines there, and they're still being used, I believe, at the base of the SLS, and then the RL-10 is in the middle somewhere.
Yes.
What else do we have going on in the SLS?
We also provide the auxiliary motors for the upper stage. We provide part of the jettison motor for Orion. We provide all of the propulsion system on the crew module, and then we're also working to support the European service module, so motors there to help maneuver it.
Okay, which one is on the upper stage? Which engine is on the?
The RL-10 is the upper stage engine. The RS-25 is the first stage.
So does the RL-10, is that used in the launch process?
It is. It is.
So that would be the final stage, basically, then, right?
So after that, then there's actually an exploded view here.
Oh, look at that! Hey, how about that? We'll take a quick look at that there.
And then this is the actual SLS. So you can see at the bottom is the RS-25 engine at the base. So like as you said, that's the refurbished space shuttle main engines. And then we have the RL-10, which is the upper stage engine for the second stage. And then once that detaches, then you've got from Redmond some R4D engines. I think there's about 12 of them there. And then another 8 to 10 scattered throughout the crew module and the jettison motor to help move things around. So A lot of content, a lot of engines. It's an exciting time for sure.
And those 8 to 10, those are like maneuvering engines, right?
They are, yes.
Okay.
Control.
All right. So what was there was an R something that you mentioned in there in the middle there.
The R4D.
That's the one. What does that do?
I believe that's to help with maneuvering.
Okay.
It's a pretty heavy system.
Of course. Well, the whole thing is a heavy system, isn't
Yes.
it? So when these things get ready to launch, like, is everybody at Aerojet Rocketdyne on pins and needles watching this and waiting to happen?
Absolutely. We had a lot of people fly down to Florida a couple of times to see the first Artemis 1 launch. That was a very, very exciting time for us. And then we also had launch watch parties at our facility. The entire site's just been super excited to see Artemis go and to keep supporting Orion and SLS.
And so far it seems to all be working as expected.
Yeah, very successful so far. We're really excited about it. NASA really focuses on reliability and safety, and we've been working really hard to make sure that happens.
So the one other thing I should ask you while I have you, Sarah, I know that there's been sort of a move to alternative fuels. Where are we in that process?
So Aerojet Rocketdyne Redmond is actually heavily involved with green propulsion systems. We recently launched the GPIM mission for the Air Force, and we're also working on a new green propellant blend that we think is going to be a really good alternative to the more toxic hydrazine propellant, which is what the vast majority of our chemical systems use right now.
That's fabulous. So good for space exploration and good for the environment.
Yeah, we're very excited to see where we can go with that, and good progress so far, but there's always more to do.
Excellent. Sarah Shark with Aerojet Rocketdyne. Thank you, Sarah.
Thank you.